Today I present the paper racism detection by analyzing differential opinions through sentiment analysis of tweets using Stack Assemble, GCRNN model, and this research explores how AI can detect racist content on Twitter using sentiment analysis combined with an advanced ensemble model. We've all seen memes or tweets online. Some are lighthearted and funny, but others cross the line, spreading harmful stereotypes or racist jokes. The problem is these spread quickly and reach thousands of people before anyone can stop them. The key question this research asks is, can AI detect racism in tweets automatically using sentiment analysis? We focus on Twitter because it's fast, messy, and highly viral, making it both an important and challenging platform for study. Here's the roadmap for today. I'll start with a bit of background and motivation, then move on to the methods, followed by the results. After that, we discuss the implication, and finally, I'll wrap up with the conclusion. Before I go furthermore, let's build a basic understanding of some key terms in neural networks. First, what is neural network? In simple terms, it's a machine learning model inspired by the human brain. It learns patterns from data like recognizing words, images, or even emotions in text. There are different types of neural networks. CNNs or neural networks are good at finding patterns. For example, figuring out which word mattered most in a tweet. RNNs and GRUs or recurrent neural networks are better at handling sequences, which means they can understand the flow of the sentence. The proposed model in this study is GCRNN, combine both CNN and GRU, which I already explained. So it will be captures word level patterns and sentence flow at the same time. On top of that, a stack and symbol means several models work together, like a voting system, to boost accuracy even further. Social media is powerful, but it also spread racism very quickly. Previous research tried models like CNNS and RNNS, but they didn't perform well on short, noisy tweets. The others proposed a stack assemble model combined with a gated convolutional recurrent neural network or GCRNN to improve detection accuracy. Here's the workflow. The dataset contained nearly 15,000 tweets in prototype. After preprocessing, tweets were categorized into positive, neutral, and negative sentiments. Negative tweets were labeled as racist. Finally, the stack and symbol GCRNN model classify and visualize the result. Preprocessing is critical for accuracy. Here's an example. The raw tweet is full of noise, but the clean version becomes readable for the model. This step removes irrelevant content and highlights terms that may indicate racist language. The system produced both tabular result and graph. Each tweet would assign a sentiment and racism label. Out of nearly 170,000 tweets, 31.5% were labeled as racist. In terms of accuracy, logistic regression detects 95% of racist tweets, SVM 96%, but the purpose of GCRNN achieved 97 to 98%, making it the best performing approach. Here is the example of the web. You can upload the file and you can press clean data. The program will clean the data, and you can just start analysis your data set. The dataset contained nearly 170,000 tweets. About 31.5% were negative, meaning racist content. That's not a small number. Nearly 1 in 3 tweets in the dataset had racist remarks. Most tweets from the US and UK were neutral. Nigeria had the highest positive sentiment, while South Africa had the most negative tweets. Discussion and implication. The key insight are preprocessing is essential. The stack assemble GCRNN outperforms simpler models, and multi-class classification is more realistic than binary racism. However, the limitation exists. The system is in real time, and only English tweets were analyzed. Despite this, the study shows how such a system could be scaled. To conclude, racist comments are increasingly common on Twitter and need to be automatically detected. The purpose stack assemble GCRNN, combining GRU, CNN, and RNN, achieves state-of-the-art result of 98% accuracy overall and only 30% misclassification of racist tweets. This proved the model effectiveness, but the work can be extended in the future. With real-time monitoring, multi-language support, larger datasets, and newer models like transformers, that would make the system even more robust and scalable. Thank you.